What's up, guys? Today we are ready to solve some new things out here. So out here we are ready to solve some problems. So we have a problem which goes something like this. So we have a circuit and the magnitudes of inductance across the magnitude. Okay, let me just draw before I say something. We have an input voltage out here, and then we have a resistor over here. We have a capacitor C over here, and we have an inductor over here. Cool, guys. So this is L over here, this is C over here, this is R over here. The input is having a phase of 0 degrees and 5 volts maximum. So it's given V of L equals V of C equals 2 times V of R. Okay. To find inductance of coil. So let's just try finding inductance of coil, which is L over here. So okay, and this condition is true at resonance. Okay, since since it's a series circuit out here, so voltage across the capacitor and the inductor are just going to be equal and opposite out here. Okay, and the current is just going to be only through the resistor over here. So it's a series resonance circuit. Okay. So at resonance, the current through the resistor is just going to be the input voltage divided by the resistance R over here. Okay, so here the V of R is the current through the circuit over here. Okay, so let's just try finding I of R. I of R is just going to be the input voltage, which is 5 volts with a phase difference of 0 degree divided by the resistance R. The resistance R of the circuit is 5 ohms. Forgot to mention this. It's 5 ohms out here. So let me just write it as 5 ohms over here. Okay, so IR is equal to 1 ampere. Okay, with a phase angle of 0 degrees over here. So now we're interested at resonance, so this condition is true at resonance. Now we are interested in finding the voltage across the inductor out here. Okay, which is 2 times the voltage across the resistor over here. So we are not interested in finding the voltage across the inductor, but we are interested in finding the inductance value out here. L. We are interested in finding L. Inductance of the coil L. Okay. So we have it's given that the voltage across the load is equal to 2 times V of R. Okay. Now the voltage across load can be written as the current I in the circuit multiplied by the impedance of the inductor. Okay, so let me write Z of L over here. So this can be written as I into Z of L. Z of L value is the value of Z of L is, I guess, our impedance value is 2 pi F times L over here. Okay, or you can just write as I multiplied by WL over here, where W is 2 pi F. Okay, now we know I is 1 ampere over here. Okay, and the value of WL, okay. Okay, we don't know the value of WL over here, so V of L is equal to WL over here. Now since it is resonant circuit out here, the potential difference across the resistor is I times R, or V of R is I times R. I is 1 ampere, so this is 5 volt. Okay, but here it is given V of L is equal to 2 times V of R, which is a 10 volt. Okay, so this is 10 volt over here. Okay, so V of L equals 10 volt equals WL. So we have got a new equation, 10 equals W times L. Okay, we are interested in finding L over here. Now let the input frequency be 50 Hertz over here. So let's just assume the input frequency is 50 Hertz. Okay, resonance takes place at 50 Hertz. So what we can get over here is 10 equals 2 pi, then we have 50 Hertz over here multiplied by the inductance L. Therefore L is just going to be 10 divided by 2 pi times 50 Hertz. So this is just going to be equal to 10 divided by 100 pi, which is just going to be equal to 0.1 divided by pi Henries. Okay guys, let me just see if it's recorded. Okay, it is. Next circuit we have we have another problem. So next circuit is goes something like this. We have a current source and so we are interested in finding the potential difference across PQ. So to find potential difference across PQ. So first we are interested in this part of the curve. Okay, in this part of the curve, and second we'll be interested in this part of the curve. Okay, so we are interested in these two parts of the curve. Okay, so we can write out here this is a 2 ampere. Okay, so we can write Kirchhoff voltage law. Apply Kirchhoff voltage law at P and Q. Okay, first let's take the point P. So at point P you can see that 2 ampere is the current flowing. Okay, so we have 2 ampere over here. So since you see the direction of current is this side out here, it's flowing inside the node P over here, and out here it flows outside the node Q over here. Okay, so it's a 2, then it is these two nodes now. So it is 10 volt minus the voltage across P divided by the resistance which is in between, that is 2 ohms. Okay, this is amperes over here, and then we have plus the potential drop across 8 volt over here. Okay, so it is V of P divided by 8 ohms over here is equal to 0. Okay, and at Q we have minus 2 ampere because it comes outside. Okay, then we have plus 10 volt minus Vp divided by 4 ohm, this is 4 ohms, plus V of P, which is 10 volt over here, and out here we have 6 ohm over here. Okay, so it is 10 volt and 6 ohms. Okay, so we can make this is V of Q, guys. V of Q divided by the potential drop out of this part, so just 6 ohm, is equal to 0. Okay, so let's see what we have done. We have calculated the current, the potential drop across point P, across 8 volts and across 2 volts. Okay, similarly we have calculated potential difference across these 3 points. So we have taken all the resistors into account. Okay, so out here for P we have 2 amps plus 5 amps minus Vp by 2 plus Vp by 8 over here is equal to 0. So 7 amps plus 8 over here, so it's 4 plus 1, so it's minus 4 plus 1 over here is equal to 0 times Vp. I just forgot to put Vp. Okay, so 7a, let's make it like this, 7a plus minus 3 by 8 V of P V of P is equal to 0. So 7 equals 3 by 8 V of P. Therefore V of P is equal to 7 into 8 divided by 3. Okay, so it's 56 divided by 3. Okay, next at Q we have minus 2, 10 minus V of R divided by 4, so it's minus 2 ampere plus 10 minus V of R divided by 4 ohm plus V of Q by 6 is equal to 0 over here. Okay, so let's this is Q over here. Let's try simplifying this. That's minus 2a plus 5 by 2 ampere minus V of Q divided by 4 plus V of Q divided by 6 is equal to 0. So is minus 4 plus 1 is going to be 1 by 2 over here equals VQ (24) 6 minus 4. So it's 24 by 2 into 2 over here equals V of Q over here. So V of Q is going to be equal to 6 volts. Okay. Okay, so the potential difference across PQ is equal to VQ minus VP is equal to 6 volts minus 56 by 3 volts. Okay guys, so the next problem we are going to solve is we have a circuit, something like this over here. So this is 100 volts out here, this is 14 ohms, this is 1 ohm over here, this is 2 ohms over here, this is 40 volts, and the resistance this is R. So here we are interested in finding the value of resistance, or sorry, aim is to find this value over here. Okay, so let's just call this point as V over here. So to find potential difference across element R. Okay, so we use a nodal analysis method. So according to nodal analysis method, we have V minus 100 divided by 14 over here, so we have let me just show you guys, we are interested in these elements over here. Okay, out here we are interested in these elements. Let's just try writing them. It's a V minus 100 divided by 14. So let this be a point, 2 points out here. Okay, we are interested in finding the resistance R in this circuit over here, guys. Okay, not the potential difference across the element R. We are interested. Potential difference across R is nothing but out here it's 100 volts, and out here it's 40 volts. Both are in the same direction, so you can just subtract. So if you just take an voltmeter and if you just measure out here, you will get 60 volt over here. So this is 60 volts over here. So it's V minus, we are interested in finding the resistance R in this circuit over here. Okay, so let me just write it down. Find R in circuit. So guys, let me think what I can do about this. So before we start, out here, if you know the values of current in these two circuits over here, in these two circuits out here, since this is the ground circuit over here, okay, so since if you know the current through these two circuits, if you add them up, then that will be the current through the resistor R over here, okay, and once we know the current, we can find the equivalent resistance. So our primary aim is to find V out here. Okay, so let's just try to apply Kirchhoff voltage law. Now we get V minus 100 divided by 14 ohms, okay, plus V divided by 2 ohms plus V minus 40 divided by 1 ohm is equal to 0. So out here we have 14 ohm over here in the denominator, so it's V minus 100 plus 7V plus 14V minus 14 into 4 is it's 5560 over here is equal to 0. Okay, so you can just rewrite times as 7, 21, 22. 22V is equal to 660. So V is just going to be equal to 30 volts. Okay guys, I hope this is clear over here. Now we have got the value of V, which is 30 volts. Now what we can try and do is calculate the current through R1 and R2, so this 14 ohm and 1 ohm resistor. So current through current through 14 ohm is 100 minus V divided by 14. So it's 100 minus 30 divided by 14. This is going to give me 70 by 14 amps. Okay. Similarly, current through 1 ohm is 40 minus 30 divided by 1 ohm. So it is 40 minus 30 divided by 1 ohm. So it's going to be 10 amps. Okay. So total current is 70 by 14 plus 10, okay, which is equal to 14, 140, 70 70 into 2, so this is 700 plus out here it is times 14, so it's 140 over here. So 840 divided by 140, so which is 84 divided by 14 ampere. Cool guys. So next what you can try and do is calculate the potential. We know the value of potential over here, across R. Potential across R so the potential across R is given by 100 minus 40, which is 60 volt. So the resistance R is given by 60 divided by 84 divided by 14. Okay, so this is the value of resistance R. You guys can calculate it. I'm not going to do that. So now we come up with another sum. One sec guys, so let me see if I have. Okay, cool guys. So out here we have a resistor R over here. We have another resistor R. So given at t equals 0, the switch S over here is closed. Okay. To find voltage across inductor at t is equal to 0 plus, it is at time t is greater than 0, it's not at 0. Okay, So you guys know, at t equals 0, the capacitor is short. Okay, so let's just rewrite the diagram. So I guess it's a positive voltage. So since it's a short circuit, we have a resistor over here. And I guess we have another resistor. Then we have an inductor. Okay. T equals 0 over here. It's 3 ohm, 4 ohm. It's 3 ohm over here, 4 ohm over here. And then it is 4 ohm and 4 Henry. It's 4 ohm over here, it's 4 Henry over here. Cool, guys. So the voltage across the inductor V of L is going to be nothing but the input voltage. Okay, so here we don't know the value of current, so we are going to use the voltage divider rule to find voltage. So so before we get to that, so to make things clear, let's just try simplifying the circuit out here. So out here the net resistance is this part of the circuit, 1 by R net is equal to 1 over 4 plus 1 over 4 over here. Okay, so 1 over R net equals make a 4 over here, 1 plus 1 over here. Okay, four by 2 is equal to 2 ohms over here. Also R net plus 3 ohm equals R cap. This is the equivalent resistance of the circuit. Two plus 3, 5 ohms. Cool, guys. So R hash equals 5 ohm over here. So the voltage across the inductor is going to be the input voltage divided by the net resistance R net multiplied by R net. Okay, if you're wondering how this has come over here, then this is due to voltage divider rule. Okay, guys, this formula is from voltage divider rule. So let's just try substituting values. V of L is going to be, input voltage is 10 volts, this is 5 ohms multiplied by I guess it's 2 ohms over here. Okay, so it's 20 by 5, which is equal to 4 volts. Okay. Okay guys, this is it guys. In the next video we're gonna try and solve some more problems out here. So I'll try and catch you guys in the next video. Until then, have a nice time guys.